All right, so today we are going to do more proofs. These proofs are going to be a little bit more tough than yesterday's lessons. All right, but with more proofs, we have more properties and theorems. These are called the Pythagorean theorem properties for trigonometry. We know Pythagorean theorem as a squared plus b squared equals c squared. Well, for trigonometry, we have cosine squared x plus sine squared x is equal to 1. That's a very important property. You have to remember it, you memorize it. And then that property comes in different forms. It can be this original form, or sometimes they change the equation around so that that's another version of the property. Notice all they did was subtract the sign to the other side. This is another version of that property. It's just the same equation, just the things have been moved around. But all three are the same thing. Here's another Pythagorean property. 1 plus tangent squared x is equal to secant squared x. That one's not as easy to memorize. But it also has different versions. If I move things around, we have that version, or we have that version. Again, all three of these are the same equation. Things are just moved around. And then the last Pythagorean property is this one. Cotangent squared x plus 1 is equal to cosecant squared x. Okay, and that also has two versions. This version and this version. Just moving things around. Okay, go ahead and write these down. They're very important, and we're going to be using them a lot. So memorize these three properties, or write them down and then leave them on the side for now. All right, let's use those properties to do some more proofs today. Today we're trying to prove that cosine squared x minus sine squared x is equal to 1 minus 2 sine squared x. All right, notice that the property that you wrote earlier, this sign was a plus sign. But this problem, it's not a plus, it's a minus. So it takes a little bit more work. All right, so try to focus on what we're trying to prove. We're trying to get to here. Notice this whole expression only has a sine in it. The cosine is gone, and so the way you try to change this side so that the cosine goes away is that you're going to replace this cosine squared with this, which if you look at the list of properties from the slide before, this was one of the properties for cosine squared. All right, so I just took the cosine squared and turned it into this. All right, and then using a little bit of algebra, combine like terms, these two combined together makes 2 or 1 minus 2 sine squared x. And that's it. We've shown that that now looks like this. Okay. Here's another example. Just so you know, this weird letter that looks like a letter B is just beta. Again, it's a Greek letter used as a variable, just like we would normally use X, but now we're experimenting with different letters from the Greek alphabet. So that's just a beta, nothing too special. All right, we have to simplify the left-hand side to make it look like the right-hand side. Okay, so it's not very easy to do, but we'll go step by step. A lot of times with these proofs, you have to kind of just recognize some things. Like this right here, you have to recognize that that's a property. It's tangent squared beta. Okay? So just remember that this is this. And then the sine beta on the bottom stays the same. Okay, from there, we do have a tangent squared, so what I can do is write it twice, because tangent squared is the same thing as tangent times tangent. Okay, so far we're getting close. We have this part, which kind of matches this part. Okay, so we're going to try to leave those alone, because that's what we want. Let's go ahead and play around with this part. What can I do to change this around? Okay, you have to think about tangent. And what's the property of tangent? From yesterday's lesson, tangent was sine over cosine. So we're going to replace this with sine over cosine. There it is. This thing is now sine over cosine. All right, notice that we can do some things to simplify. This sine will cancel out with this sine. And so now we have tangent of beta over 1 is equal to 1 over cosine of beta. And if you notice, this is a property from yesterday. 1 over cosine is secant. And there you have it. We have shown that. I know, it's not the easiest thing to do. It's kind of tricky. We are going to practice this quite a few times. Okay, let's go ahead and do another example. This one's a little bit different because it does not tell you what it should equal. You actually have to simplify as much as possible to get it down to a non-fraction single term. All right, so let's go ahead and simplify, and hopefully it simplifies down as much as we can. First thing we do is go ahead and take this and distribute it in. Distribute it in. Pay close attention to this plus sign. That just means there's two terms, one term here and one giant term there. You do not distribute it again to here just because these two are considered one term, so don't make that common mistake. All right, let's go ahead and distribute. That's what we have. From yesterday's notes, I said that it was easiest if you change everything to sine and cosine. That's still pretty much the case in today's lesson. So let's go ahead and change this to a property that has sine and cosine, this to a property that has sine and cosine, and this to a property that had sine and cosine. Hopefully you remember those properties. That's that. Tangent x is equal to that. Tangent x is equal to that. And then cotangent is equal to that. All right. Let's see what we can do here. At this point, you can cancel some things out. Notice this cosine cancels out with that cosine. This sine cancels out with this sine. And then, of course, you cannot do this canceling this out, only because this plus sign is there. So when the plus sign is there, you cannot cross cancel like that. You could only do it within the side. So those cosines do not get canceled out. All right, once we've canceled some stuff out, we can go ahead and simplify. Notice that you have these two together, so you can write these two as sine squared, because sine x times sine x is sine squared x. And then just everything else is cosine is there, and then this cosine is there. Okay, so now we've simplified it just a little bit, but we still have too many terms. We have to now go back to the 6th grade and remember how to combine fractions. You have to remember how you get two fractions so that they're 1. And the main rule is to get a common denominator. All right, how do we get these to be the common denominator? We have to change this one. We need it to be a cosine. And then the rule in the 6th grade was, in order to change this denominator to a cosine, you have to multiply the top and the bottom by cosine. So multiply this and this by cosine. Okay? So now the top becomes cosine squared, and the bottom is cosine. Now notice the whole denominator has the same denominator. When it's the same denominator, you can write the two fractions together. There it is. There's the two fractions together. And then you have to recognize something about this. It is a property. Sine squared x plus cosine squared x is 1. All right, and we're almost there. 1 over cosine, you should remember, is secant. There it is. All of that work just to get down to one word, secant x. Okay, this is the last example for the day. We have to change this whole side to make it look like cotangent of sigma. This little symbol right here, it just stands for sigma. It's a lowercase sigma. Again, it's just a Greek letter. Just like our variable x, it's just sigma. All right, so let's go ahead and try to simplify the left side as much as possible. Okay, again, our common rule of thumb is to change everything so that it's related to sine and cosine. In this problem, secant can be changed. Remember, secant is 1 over cosine. So there it is. 1 over cosine is the same thing as secant. And notice this sign is still here. Nothing to change there. All right, now we have two fractions. Again, in order to make two fractions one fraction, you need a common denominator. You have to think of how to get these two denominators to be common. Okay, if only you had a sign here, that would make it common. And so you can put a sign there, but remember, if you put a sign there on the bottom, you have to put another sign on top to make it still equivalent. So let's go ahead and put the signs there. Okay, notice that now we have a sign, but then on top it's a sine squared because there was already a sign. So sine times sine is sine squared. Okay, now that we have a common denominator, we can write these two fractions as one fraction. There it is. The common denominator is right there. And then the top is just 1 minus sine squared. And hopefully you recognize that this right here is a property. Think about what property it is. It is cosine squared. Okay. Now we have cosine squared. we can do some simplifying. We can cancel one of the cosines with one of the cosines down here, and we're left with cosine sigma over sine sigma. And then finally, you should recognize that cosine over sine is cotangent, what we were trying to prove. Okay, now I understand that these proofs are not very easy. They can come out of nowhere. The process is not intuitive, but we will practice a few more of these. So hopefully the process of doing them will help you understand them better. But that is all for today.